Hi everyone, Piet Callemeyn here. Welcome back again to this wearable design project where we are going to take this layout and finalize it in a rigid flex design. So this is where we left off. Everything is still on top layer. The first thing I would like to do is to combine the controller in a lower layer or in the bottom layer with the charging system that is in the top layer. One thing we need to keep in mind is there is an antenna over here. It should be placed where there's nothing on top. So we'll have to make sure that we shift it a bit over here or maybe a bit on the side underneath here. We do have an inductor over here. So it's not ideal to have, let's say, this one on top of that antenna. That's I think the worst that we can do. Also over here there is a connector. It's a metallic connector. So if I would place, let's say, the antenna underneath like this, there would be no real connection. Also on the side, maybe we are a bit close to that antenna. What I think is most interesting in our design is that we try and put it somewhere over here. Then we are a bit above that inductor. And then also in terms of, let's say, BGAs, because we have these BGAs, we will have to use vias in PAT. Same thing over here. We might have the need for a couple of vias in PAT for the microcontroller. So let's put it over here. And then the battery connector, I'm going to shift that one out a bit lower over here, so to be not too close here near these pins. So in 3D looks like this. Again, keep in mind for the production variant this will typically not be placed. And then one thing remaining is that pogo pin connector that we have. So this one is used to flash the controller. For now I'm going to leave it over here. I'll make the PCB a bit smaller to see where we are. So for that, we go to board planning mode. We edit the board shape. I'm going to draw this in all the way to the edge over here. And then all the way to the edge of the microcontroller as well. I think in terms of height, this is what we should aim for. And then also we still have this connector. So we can draw the board in on that side as well, as close as possible to these capacitors. So this is where I would start with. Now we still have this connector over here. This one is actually the connector to flash the microcontroller. So it has a power supply on board, ground, and then there's a reset signal and the clock line and digital I/O line. So this is the one that we need to flash the system. We are also going to look at the end of the video to maybe repurpose this one. It could be interesting because we still have that USB connector on here. It could be interesting to use this connector to charge the system and to also program the header and to maybe also have USB connectivity. So I'm going to show you how we can repurpose this one and maybe get rid of this connector over here. For now, I think the best place we could put it is somewhere on the side. It's a bit further away from this microcontroller, but if you're going to put it over here, we might have contentions with these holes that we have on the sides. So I will go ahead and put this one over here. It's on the bottom. So it looks like this. You push on your connector and you're going to be able to flash the system. Here, this will be on the side, this will be open. For now, let's assume that we can live with that. This one, we need to check with our actual connector if we can push it on, but I can assure you this will work. So that's for starters. Now, I wanted to show you how you could work with rigid flex design as well. It all depends, of course, very much if you need it. Depends on the housing that you have. So it's very dependent from design to design. Take in mind as well that this is an expensive solution. But to be fully complete in this video, I want to show you how to do it. So first of all, we need to open the layer stack manager. And then inside the layer stack manager, I see that we are now just working with the standard 2-layer design. So we're going to add a plane below. And it will automatically include 2 planes for you. So one will be a ground plane, another will be a supply plane, or you could use 2 ground planes, whatever you like. Important thing is if you're going to use flex, that you select rigid flex over here. Okay, so we have this. Then we add an extra stack to that. And what we are going to get rid of, so this will be our flex stack. We will get rid of all the layers except for the bottom layer and the layer number 2. So we will leave these in place. And then for a flex, what we also have to add are the cover lays. So basically cover lay is like solder mask that you would have, but it's in a flex. So for that, it's important that we can give the name, but that we include, or that we check the is flex. You've seen there was no cover lay option. If I now do a right click, insert layer above, we have a cover lay. So you go ahead and add that, the cover lay. You also need to add an overlay. And then we do the same thing for the bottom layer. So we insert a layer below. That's the cover lay first. And then we insert another layer. That has to go below the cover layer, of course. Insert layer below. That is called overlay. Okay, so then we have our standard board layer stack for the rigid parts and the flex stack for the flexible parts. So now that the layer stack is set, we can continue in our next video to finalize our rigid flex PCB.